chapter 4, that is quadratic equation. Right, the first question is solve the following quadratic equation by the method of factorization. So looking at this question, we have a root 3x square plus 10x plus 7 root 3 is equals to 0. Now we have to solve this by method of factorization. So what we have to do, we have to just multiply the coefficient of x square with the constant. So that is equals to root 3 into 7 root 3 will be 21. So we have to find the factors of 21 such that their sum is equals to 10. So it means that is 3x and 7x. So now split the middle term. So we have a root 3x square plus 3x plus 7x plus 7 root 3 is equals to 0. Now taking common from the first and the second term, we have a root 3x within bracket x square plus root 3 plus 7, then within bracket x plus root 3 is equals to 0. Now we can see in both the bracket we have the same term. So again this term is common, so we have taken this term as common, that is x plus root 3. Then here the remaining term is root 3x, so we have written here root 3x. Here it is plus 7, so we have written plus 7 is equals to 0. So now we have two factors, so it means the product is equals to 0. It means either we have x plus root 3 is equals to 0 or we have root 3x plus 7 is equals to 0. It means x equals to minus root 3 or x equals to minus 7 upon root 3. So these are the two roots of the given equation. So now after this, if we see the next part, that is a part second, it is 1 over x minus 2 plus 2 over x minus 1 is equals to 6 upon x. So how to solve this? So first we take the LCM of the left hand side, so x minus 2 into x plus 1. Now doing the cross multiplication, because we have the different denominators here, so 1 into x minus 1 and 2 into x minus 2 is equals to 6 upon x. Now on solving this, x, this is 2 into x, 2x plus x is equals to 3x, minus 1, this is minus 4, that will be minus 5. So we have here 3x minus 5 over, now if you multiply this, we'll get here x square minus 3x plus 2 is equals to 6 upon x. Now after this, what we have to do, we'll do the cross multiplication. So in that, now we have 3x minus 5 into x, which is equals to 3x square minus 5x, and then 6 into x square minus 3x plus 2, which is equals to 6x square minus 18x plus 12. Now we'll do the grouping. Grouping means keeping the like terms together. So we'll bring all the terms from the right hand side to the left hand side. So we have 3x square, then this will become minus 6x square, and then minus 5x, this will become plus 18x, and this minus 12. On solving this, suppose we are getting here minus 3x square, then plus 13x minus 12 is equals to 0. So normally we don't keep the negative sign with the x square term, so we just multiply all the equation by the whole equation by minus. So the result will be 3x square minus 13x plus 12. Now we have to split the middle term, so we have 3 into 12, 36. Now factors of 36 as their sum is equals to 13. So that is, we have 9 and 4. So since we need here minus 13, so we have minus 9 and minus 4. So we have 3x square minus 9x minus 4x plus 12 is equals to 0. Now taking common from the first and the second term, okay, so we have 3x, this is within bracket x minus 3, then minus 4 is taken as common, we have x minus 3. So this is clear that within the bracket we have the same term. If you are not getting the same term, it means something is wrong somewhere. So we have to look for the common term as well as the sign. Now after this, now x minus 3 is common, so we have taken x minus 3. Now here the remaining term is 3x, here it is minus 4, so 3x minus 4 in the other bracket is equals to 0. Either we have x minus 3 is equals to 0 or we have 3x minus 4 is equals to 0. It means x equals to 3 or x equals to 4 upon 3. So these are the two roots of this equation. Okay, now in the third part, we can see it is given 2x over x minus 3 plus 1 over 2x plus 3 plus 3x plus 9 whole over x minus 3 into 2x plus 3 is equals to 0. So what we'll do here, we'll just keep this value to the right hand side. So we have changed the sign minus. Now taking the LCM of this both, so we have x minus 3 into 2x plus 3. Now multiplying this 2x by 2x plus 3 and 1 by x minus 3. So this we have done. Now what we can see here, we can see here this whole upon and this whole upon is the same term. So we can just cancel out these from here and here. Looking at this quotient, continuation of that, we have here 4x square plus 6x plus x minus 3 is equals to minus of 3x plus 9. Now so we are transferring these minus of 3x plus 9 to the right side, so there will be plus 3x and plus 9. So now doing the grouping, so we have 4x square only one term, so we'll write only 4x square, then 7x plus 3x will be 10x, and minus 3 plus 9 will be plus 6 equals to 0. Now we can take 2 common from all these, so we can write this as 2x square plus 5x plus 3, means 2 has been taken out, right? And then that 2 if we transfer to the right side, so this will become 0 upon 2, and 0 upon 2 is 0. So this is the reason why we have converted this equation in the standard form or the simplest form here now. So this is of the form ax square plus bx plus See now, doing the method of splitting the middle term, we have here 2 into 3 is equals to 6, as well as 2 plus 3 is equals to 5. So splitting 5x into 2x and 3x, so we have 2x square plus 2x plus 3x plus 3 is equals to 0. Now taking common from the first and the second term, so we have 2x is a common, so remaining term is x plus 1. Here 3x is a common, so again remaining term, sorry, here 3 is a common, so here the remaining term is x plus 1. So now we have here x plus 1, so x plus 1 we have taken as common. Now the remaining term is here 2x and here plus 3, so 2x plus 3 is equals to 0. It means either we have x plus 1 is equals to 0 or we have 2x plus 3 is equals to 0. It means x is equals to minus 1 or x equals to minus 3 upon 2. But x equals to minus 3 upon 2 is not possible. The reason is very simple, because if we write here this as, yes, this x is equals to minus 3 upon 2, then whole this will become 0, and something above 0 is not defined. Same here, something upon 0 is not defined. So this is the reason why we can't take the value of x is equals to minus 3 upon 2. So we have to only take the value x is equals to minus 1. That is the only solution. Now looking at the next question, we have here 4x square minus 4ax plus a square minus b square equals to 0. Now solving these questions with the quadratic formula or the Dharacharya method is very easy, but if the question is solved it only by the factorization, then we have to take care of this. So look here how to solve this question. So first of all, we can see here that the a is here 4 and the c is here a square minus b square. So as we know that a square minus b square can be written as a plus b into a minus b. Now if we multiply this by 4, then we have 4 a square minus b square, so we have written here 4 a plus b into a minus b. So now we can write 4 as 2 into 2, so one time we are multiplying this by the first terms in the bracket and the second by the second terms in the bracket. So we have 2a plus 2b into 2a minus 2b is equals to, we have 4a square minus 4b square. Now we need to get the minus 4a as the middle term. So how to write this? If we simply add this 2a plus 2b, 2a minus 2b, then the result will be 4a, but we need to have minus 4a, that's why we have written this as minus within bracket of 2a plus 2b and plus 2a minus 2b. So if we solve this, we'll get the result as minus 4a. So it means we are just in place of minus 4a, we are writing here 4x square minus bracket twice of a plus b plus twice of a minus b, bracket close, into x, a plus b into a minus b. So now, so this we have taken 2 already as a common. If you wish, if you don't want to take common, then we can write as it is. So now after this, we are multiplying both the terms by x. So we are getting a 4x square minus 2 into a plus b into x, then minus plus minus minus 2a twice of a minus b into x plus a plus b into a minus b. Now we are taking common from the first and the second sum. So what is common here? Common is 2x. So we have taken 2x here common. So now the remaining term is here 2x minus of a plus b. Now what is common here? It is common is a minus b here. So we have taken minus sign also. So if we have minus a minus b is common, so within bracket we have 2x minus of a plus b is equals to 0. So we can see here in both the brackets we have the same term, so this is again common, so we have taken this as common. The remaining term is 2x and 2x. We have written minus of a minus b, minus of a minus b have written equals to 0. So either we have this equals to 0 or this equals to 0, that is 2x minus of a plus b is equals to 0 or 2x minus of a minus b is equals to 0. On solving this, we will get here 2x is equals to a plus b or x equals to a plus b upon 2. Here 2x is equals to, yes, this minus will come plus, so a minus b over a minus b, then x is equals to a minus b over 2. So these are the two roots of this equation. This is done by the method of factorization. Okay, so after this, the next question we have is this. Looking at this question, we have here a square b square x square plus b square x minus a square x minus 1 is equals to 0. So what we can do here, we can just simply take the common from the first and the second term and third and the fourth term. So what is common here? We can see here a square is here, a square is not here, so it's not common. B square is here, so b square is common. X square is here, x is here, so x is common. So b square x is common, so remaining term is a square x plus 1. Now we have taken here nothing is common means 1 is common, so we have taken minus 1 as common, so within bracket we are getting a square x plus 1 is equals to 0. So we can see here in both the brackets we have the same term, so it means it is common again. So now remaining term is b square x minus 1. So either we have a square x plus 1 is equals to 0 or we have b square x minus 1 is equals to 0. It means x equals to minus 1 over a square or x equals to 1 over b square. So these are the two roots. Okay, so now looking at this question, this is one of the very important, the good question. Okay, yes, but the question which are discussing today is actually they all have already yes, they all have come in the board exams. So just see here. So now we have here 1 over a plus b plus x is equals to 1 upon a plus 1 upon b plus 1 upon x. So what we are doing here, we are just taking this 1 over x to the left side, so they become minus 1 upon x. Now taking the LCM here, so LCM will be x into a plus b plus x, then cross multiply x minus of a plus b plus x is equals to, now here the LCM will be ab then b plus a. So just removing the bracket, we are getting x minus a minus b minus x over x into a plus b plus x is equals to a plus b over ab. So this a plus b and this if we take common from this minus a minus b minus sign, then we'll have a plus b. So a plus b and a plus b cancel out. So here we remaining term is here minus 1 and here 1. So in the denominator we have x into a plus b plus x is equals to, here we have upon ab. So now cross multiply, so minus 1 into ab will be minus ab, then 1 into this will be x into a plus b and plus x square. So what we have done here, we have just written here x into a plus b and x square. So we can see now converting this in the standard form, so we have x square plus a plus b into x plus ab. Now what we have to do, we just split this, so just multiply a by x and b by x. So we are getting here x square plus ax plus bx plus ab. Now x into x plus a, this is common here, then here b is common, so again we have that term x plus a in the bracket. So now we can see we have x plus a common in both the brackets, so we take it as common. So now here remaining term is x, here it is b, so x plus b. So it means either x plus a is equals to 0 or x plus b is equals to 0. It means here that we have x equals to minus a or x equals to minus b. This is our answer. Now the next question, question number this one, we have to solve x equals to 1 over 2 minus 1 over 2 minus 1 over 2 minus x, where x is not equals to 2, because if x equals to 2, then this will become not defined. So what we'll do, first we'll take this term 2 minus 1 upon 2 minus x. So here the LCM will be 2 minus x, this can be written as 2 upon 1, so 2 into 2 minus x minus 1 whole over 2 minus x. Now we just solve this, this will be 4 minus 2x and this minus 1. Now here, now this 2 minus x will go here. The reason is because as we know that a upon b whole upon c upon d, it means a into d is equals to b into c. Using that, so we are getting here x equals to 1 over 2 minus this 2 minus x will go here, 1 into 2 minus x over 4 minus 2x minus 1, that will be 3 minus 2x. Now again taking the LCM, so this 2 has to multiply by 3 minus 2x, so 2 into 3 minus 2x minus of 2 minus x. Now this 3 minus 2x will multiply with this 1. Okay, reason is same, that is a upon b whole upon c upon d is equals to ad into bc, ad over bc. So after this we can see here, now we have here x equals to 3 minus 2x over just multiply this, we get 6 minus 4x minus x minus 2 plus x. So x equals to 3 minus 2x over 4 minus 3x. So we have here x into 4 minus 3x equals to 3 minus 2x. On solving this, we are getting this into the standard form as 3x square minus 6x plus 3 is equals to 0. So we can take 3 as a common, so we have here x square minus 2x plus 1 is equals to 0. So this is the whole square of x minus 1 whole square is equals to 0. So it means x values will be 1 and 1. So these are the solution, or we can say here the roots of x. Okay, after solving this, let us try to solve the based on the nature of the roots. Nature of the roots, as we all know, discriminant is equals to b square minus 4ac. So if b square minus 4ac is greater than 0, then the roots are real and distinct. If b square minus 4ac is equals to 0, roots are real and equal, and if b square minus 4ac is smaller than 0, roots are imaginary. Okay, so that means the third case we are not we don't have in our syllabus, and we are not supposed to find the root. So we have only the first and the second case. So looking at this question, find the value of k for which the equation x square minus 4x plus k is equals to 0 has real distinct roots, so it means we have here x square minus 4x plus k is equals to 0. So the standard form is ax square plus bx plus c is equals to 0. On comparing here, we have a is equals to 1, b is equals to minus 4 and c is equals to k. So as we know, d is equals to b square minus 4ac, so putting the value b is equals to minus 4, then a is 1 and c is k equals to 16 minus 4k. So as we know the condition, that is d is greater than 0, so it means b square minus 4ac greater than 0, that means 16 minus 4k is greater than 0. So this can be written as 4k smaller than 16, because when we shift this, okay, and when we have to change the sign, we change the sign of greater to smaller, smaller to greater. So we have 4k is smaller than 16, so it means k is smaller than 4. So if k is smaller than 4, then the given a quadratic equation will have the real and distinct roots. Now second is find the value of k for which the given equations has real roots. So condition is same. So using the same procedure, first we will just compare this with the standard form ax square plus bx plus c is equals to 0. So we have here a is equals to k, b is equals to minus 6, c is equals to minus 2, putting the value d is equals to b square minus 4ac, so we have minus 6 square minus 4k into minus 2, which is equals to 36 plus 8k. So as we know, here the roots are real, so roots are real means d is greater than or equals to 0. So 36 plus 8k is greater than or equals to 0, so it means 8k is greater than or equals to minus 36. So k is, just divide this by 8k is greater than or equals to minus 36 upon 8, that is minus 9 upon 2 is the answer. That is k is equals to or greater than minus 9 upon 2. Then in this part we have 9x square plus 3kx plus 4 is equals to 0. It means ax square plus bx plus c is equals to 0. On comparing with the standard form, we have here again a is equals to 9, b is equals to 3k and c is equals to 4. So we have d is equals to b square minus 4ac. Putting the values, we are getting a 9k square minus 144. So condition is same, that is d is greater than or equals to 0. So 9k square minus 144 is greater than or equals to 0. It means 9k square is greater than or equals to 144. So here we have k square is greater than or equals to 16. So it means if we find the square root, it will be plus minus 4. So in such case, we have k is smaller than or equals to minus 4 or k is greater than or equals to 4. So condition is this: if, that is, since x square minus a square is greater than or equals to 0, it means x is smaller than or equals to minus a and x is greater than equals to a, means smaller than the equals to the negative values and greater than equals to the positive value. So in this way we have to solve. Okay, so just practice all these questions. If in case you find any problem, you are most welcome to ask. Okay, and solve these questions here. They are fair copies. Thank you very much.